I'm going to begin by giving a brief history of Pythagoras and the Pythagorean theorem. I will then go into a geometry lesson on the Pythagorean theorem using GeoGebra. Pythagoras is one of the most recognized mathematicians because his name is a part of a commonly discussed theorem, the Pythagorean theorem. Pythagoras is a mathematician, philosopher, scientist, and founder of the Pythagoreanism movement, who is said to have lived at around 570 to 500 BC. Little is known about him, as most documented information about him was written well after his lifetime, passed down orally over the years, resulting in some unreliability. What is known, however, is that he received credit for many accomplishments that likely belonged to his followers. This included the Pythagorean theorem, as well as accomplishments in the fields of music, astronomy, and medicine. Pythagoras is known to have had many teachers, traveling far and wide to learn geometry from the Egyptians, arithmetic from the Phoenicians, astronomy from the Chaldeans, and religion from the Magians. According to Porphyry, Pythagoras and Thales had the most to learn about geometry. Thales was a philosopher, scientist, mathematician, engineer, and instructor of Pythagoras. Little is known about Thales, but according to Plato, he was a man too preoccupied with his studies. Thales was the instructor who introduced Pythagoras to mathematical ideas and to astronomy, and sent him to Egypt to learn more about these subjects. Other instructors and individuals that influenced Pythagoras' work included Pherecydes, recognized as the most frequently mentioned teacher of Pythagoras, Bias of Priene, and Anaximander, who was also a student of Thales and believed that there was unity underlying all the contrasts, diversity, and multiplicity in the universe, an idea that became even more established with the rise of the Pythagoreans. Pythagoras believed that all things known have number, and he inspired and founded a society based on this belief. In terms of music, he or his followers discovered a relationship between musical pitch and the length of a vibrating harp string in creating music and harmony, noting specific proportions and ratios that account for specific sounds. Although others were aware of the relationship between string length and pitch, this discovery was significant in that it led to Pythagoras' discovery that all things known have number. The mathematical interpretation of music was said to have provided the finishing touches to the circle of related disciplines: geometry, arithmetic, astronomy, and harmonics, taught at the Pythagorean school. Pythagoras and his followers believed that even in the apparent chaos of nature, there is pattern and order hidden, and that it is possible to understand it through numbers. He believed that nature and everything in it could be reduced to numerical relations. The only idea that is believed to directly belong to Pythagoras and his original followers is the idea that numbers are a pathway from human ignorance to an understanding of the deepest mysteries of the universe. At around 520 BC, Pythagoras started a school, which was founded based on his view of the world, which he developed over the course of his travels. About 2 years later, the Pythagorean Society was established, and based on the idea that mathematics was at the heart of reality, and that symbols possessed a mystical significance that drew the human closer to the divine. Pythagoras, his devotees, and his school were obsessively secretive, referred to as an ancient cult about whom almost nothing is known, and they believed that all accomplishments were to be attributed to the teacher. Although there isn't evidence that Pythagoras actually worked on the theorem, he received the credit for many of his followers' accomplishments, including the Pythagorean theorem. Documents that included Pythagoras' name didn't come about until centuries after his death, when Pythagoreans, as well as Aristotle and his followers, began writing about him. Their writings, however, were based on materials that no longer exist, and on oral accounts from Pythagoreans that may or may not have been reliable. Pythagoras' name wasn't found in connection with the Pythagorean theorem until 500 years after his death, suggesting that the theorem was the finding of Pythagoras' followers well after his death, or Plato's followers about 200 years after Pythagoras' lifetime. Pythagoras was influenced by many and also influenced many with his work, one of which was Plato. Pythagoras' established Pythagoreanism influenced Plato, demonstrating his profound effect and influence upon others, particularly other great mathematicians and philosophers. Both Plato and Aristotle would go on to write books about and inspired by Pythagoras and Pythagoreans, well after Pythagoras' lifetime. Pythagoras' most well-known contribution to geometry is the Pythagorean theorem. Though numbers and symbols are typically used today to model the theorem as a squared plus b squared equals c squared, it can also be thought of visually as three squares coming together to have one side of each square form a right triangle. In other words, the theorem relates the squares of the lengths of the sides of a right triangle. According to this representation, the space enclosed in the square on the hypotenuse is exactly the same amount of space as is enclosed in the other two squares combined. Pythagoreans used pebbles to visualize this relationship and soon learned of what we now call Pythagorean triples, including 3, 4, 5, and 5, 12, 13. As a result of the discovery of Pythagorean triples, architects and builders became able to confidently form a right triangle without the aid of instruments. For example, by using 3 rods which are 3, 4, and 5 feet long to create a triangle, one is ensured to create a right triangle. By the 1st century BC, the theorem was being recognized as Pythagoras's, and the theorem was often attributed without question to Pythagoras. Though the Pythagorean theorem has clearly been a contribution to geometry and is recognized by some as the most important single theorem in the whole of mathematics, it has also found its way into nearly every branch of science, pure or applied. It is also likely that Pythagoras or his followers discovered irrational numbers, including the square root of 2. Since a right triangle with sides a and b, each equal to 1, will have a hypotenuse of the square root of 2, according to the Pythagorean theorem, Pythagoreans then began searching for a ratio to produce the square root of 2. Eventually, they realized it simply can't be done. It's what we now call an irrational number, since it cannot be represented as a ratio of whole numbers. This finding contradicted Pythagoras' idea that all things have known number. Ultimately, Pythagoras has made his mark on mathematics and geometry, regardless of whether or not he made a direct contribution to the famous Pythagorean theorem. He was a leader nevertheless, and the respect for him is shown through his many followers over the centuries, during his life and after his death, including Plato and Aristotle. His new perspective on life, being made up of mathematics and numbers, presented an opportunity for exploration and research, and his followers' work inspired significant findings in the field of mathematics. The Pythagorean theorem is regularly used today, and is still used for the same purposes it was used for long ago. It has also been applied to the modern day, being used and taught through various computer software programs, such as Geometer Sketchpad and GeoGebra. Pythagoras' work will continue to be further explored, and with luck, maybe some of the mysteries of Pythagoras and his direct contributions will be unveiled. Today's lesson is on the Pythagorean theorem using GeoGebra. The Common Core standards and objectives for this lesson include: explain a proof of the Pythagorean theorem and its converse, and apply the Pythagorean theorem to find the distance between 2 points in a coordinate system. Begin by opening GeoGebra. If it's not already on your computer, you can download it for free by going to geogebra.org/download. So today we're going to create a right triangle made up of squares, and we'll be able to observe the squares of each side in order to prove the Pythagorean theorem, that the first side squared plus the second side squared equals the hypotenuse squared. So using GeoGebra, we'll be able to manipulate the figures to see the relationships between them. Begin by going to the Segment tool to create a vertical line segment. Go to the Move tool to right-click on each point to show the label. So you'll have point A and point B. Now we're going to create a perpendicular line to line segment AB. First click on the line and then on point B to create that perpendicular line. Next, what you're going to do is go to the Point tool and create a point C that is on that perpendicular line. Right-click to show the label. Next, we're going to hide the line segment and the line that we've created. So right-click on each of them and go down to Show Object, and that will hide them. Next, we're going to rename points B and C. So we're going to right-click on point B and rename point B as C, rename point C as B. Now we're going to create regular polygons. So if we can go on the regular polygon tool and start with point C and then click on point A with 4 vertices, and that'll create a square. We're going to do the same thing with AB and with BC. So we're going to stay with the regular polygon tool and create squares for each of those sides. So now we have the 3 squares that make up the right triangle. And what we're going to do next is go to the Move tool, and we're going to name our sides. So we can right-click on each of the sides of the triangle and name side BC will be side A, since it's across from angle A. And the same thing with the 2 other sides. So AB would be side C and AC would be side B. Now we want to see the values for the area of each square. So you can right-click on a square and go down to Object Properties. Then make sure you're on the Basic tab and press Show Label and go down to Value. And you can close out of this window. Do that for each of the squares. So down to Object Properties, Basic, Show Label, Value. And for the third, and this is going to give you the 3 values for the 3 areas of each of the squares. So now we can move a vertex of the triangle and see that the areas of the squares change, but what is it that doesn't change? You can take this time to discuss your observations and form a conjecture. You may have noticed that the areas of the 2 smaller squares equal the area of the larger square. So in this case, 10 plus 5.18 equal 15.18. And as you move the vertex of the triangle around, this stays true. This is the Pythagorean theorem, that one side of a triangle squared plus another side of the triangle squared equals the hypotenuse squared. This can also be represented as a squared plus b squared equals c squared. Okay, so now we're going to create our own right triangle. And we're going to begin by going to the angle with the given size tool. So angle of the given size, because in order to use the Pythagorean theorem, we have to have a right triangle. So that means that one angle of a triangle needs to be 90 degrees. And we can click to make our first point, click to make our second point, type in 90 degrees, okay, and now we have our 90-degree angle. Go to the segment tool to connect our points, and then go to the move tool, and we're going to label our points. So right click and rename, and we're going to make this triangle ABC. Now we have triangle ABC, and we're going to right click on line segment AC, go down to Object Properties, Basic tab, Show Label, and Value, and that is going to get us the length of side AC. We're going to do the same thing for BC. So now we have the sides of our triangle. So knowing that our sides are 6.13 and 6.13, how can we calculate the length of AB with this information? So if we go to View and down to Algebra, here on the left-hand side, we'll have the values of our sides. Side A is 6.13, side B is 6.13, and side C is currently unknown. So now that we know the Pythagorean theorem, we know that a squared plus b squared equals c squared. So in this input, if we say 6.13 squared plus 6.13 squared equals, and here we have that equals 75.15. So side C should equal the square root of 75.15. And we can check that by putting in the square root function and typing in 75.15. Enter, and we have that our side length is 8.67. Now we can check that by right-clicking on side C, going down to Object Properties, Show Label, Value, and we have 8.67. So today we've reviewed the history of Pythagoras and the Pythagorean theorem. We've shown the Pythagorean theorem using GeoGebra, and we used GeoGebra to find the hypotenuse of a right triangle using the Pythagorean theorem.